I am going to pull this back so we can see this. All right. Hello, my name is Jacob Bradshaw. I work at Trine University, the Trine Center for Technical Training. This is a video for our Fanuc Instructor certification that we cannot wait to teach this course here at Trine. So very excited. I do have students here from NRE 262 class. So this is a PLC class. And I am here with Dr. John Liu as well, their instructor. Okay, and then Jason Bloom is behind the camera. Okay, awesome. So today we're going to talk about Fanuc robots. We're going to talk about the different coordinate systems, the different frames. You go ahead and go on the next one. Yep. So what is a coordinate system? I'm sure you guys have heard this many times in your classes here at Trine. Pretty much we live in a 3D world, right? Everything that we do, it's in a 3D type of environment, okay? So if I were to plot that on a graph, okay, we would actually move in either an X, Y, and Z coordinate system. Does that make sense? So me as a reference, standing here, this is my home position, I'm at 0, 0, but I decide to pick up this marker, that means I'm going to move so many millimeters, or inches in this case, to pick up this marker and then go back to home. Does that make sense? Okay, so that is the coordinate system. It is the measured position and orientation of the actual physical objects that are around the robot. The robot doesn't know anything. Remember that. It doesn't know anything until we tell it. Okay. All right, so move on to the next point. All right, so we're going to talk about frames. There are many frames when it comes to these Fanuc robots. The first point, we're going to identify the location of your robot. Okay. This is defined by the world frame. This guy right here. You'll find out on a later slide. This world frame doesn't change. So by default, your world coordinate system coincides with the base coordinate system of your robot. Okay, which you'll see that again on the next slide. We're also going to use frames to do what? Identify parts, fixtures, benches, whatever that robot is working off of. Okay. In order to do so, to tell the robot where my working bench is at, we have to create what's called user frames. Okay. So user frames define the point based on the parts or the work area that you have. Okay. It's also a reference frame for a lot of your recorded positions, right? Your data that you're working with. It's a little more advanced, so we're not really going to go into in depth with that. So the next one, when you have a user frame, it's used to identify any variations. So think about this. You have a robot that's going to come over here and pick up this part. Okay? And it knows it's going to come at an XYZ at this coordinate system, going to pick up this part. But your engineering manager comes over here and says, hey, we found out a way on a time study that we can make this faster if we move this 3 inches closer to the robot, right? Now what happens? Your points, your robot doesn't know a move. It still thinks it's going here, even now it's coming up to here. Does that make sense? Mm-hmm. So you need to move your reference point, your reference frame, and that is your user frame. So you can go on the robot, touch that up, right? Tell it to move 3 inches closer. Okay. Next thing we're going to talk about is your point of interest, also known as your TCP, your tool center point. So at the end of the robot, there's nothing, right? There's nothing there. If you want that robot to do something specific, like welding or picking up a fixture or picking up any type of part, you have to create an end of arm tool for that. Okay. It could be anything from a clamp mechanism, suction cup, magnet, right? There's a wide variety of different end of arm tools. The robot has no idea what that is, right? We have to teach it. We have to tell it where that end of arm tool is at. And that represents the tool frame. Okay. And the last part is jogging. We can create a jog frame. This works really well in RoboGuide. Okay. If you were to have a complex part, it's up and down, right? It's very 3D looking. If you have a very complex part or shape, a jog frame will help you move along that part. Okay, so let's go on to the next slide. You guys have any questions on that? Okay, cool. So a reminder, a typical 6-axis robot represents its roll frame as this, right? Your XYZ is 0 millimeter, and then your yaw, pitch, and roll, which is your W, P, and R axis 4, 5, and 6. Those are represented in degrees. Okay. So XYZ is how many millimeters that robot will move. So your axis 1, your axis 2, and axis 3 is based off of millimeters. This is all based off of rotation. Does that make sense? You guys have any questions on this part of it? Yes.
So the X, Y, and Z is the physical position, and the yaw, pitch, and roll are like the direction it's facing almost.
For this end, right? If you want to rotate a part, let's say it picks up a part like this, but it only goes in the fixture this way, right? So you picked it up, but to actually rotate it, the 4th axis, you would rotate it.
Oh,
Okay. Or you could do the 6th axis. So this is all about rotation. Okay. Excellent question. Thank you. All right, let's move on here. All right, so in a coordinate system, to kind of put all this in perspective, right? At your robot, that is your roll coordinate. Okay, your XYZ. Your tool, your end of arm tooling exists here. Okay, that is your tool center point. That is your end of arm tooling. So the robot knows its roll coordinate, it knows its tool center point, it needs to know the fixture that's going to, and that's these. These are your user frames. Okay, that's within that robotic cell. All right, so let's go on to the next point. All right. So real easy method to determining how you're going to move that robot. Okay, a real easy method is this. This is called the right hand rule. So if you guys hold out your hands, your index finger is pointing straight out, your thumb is going up to the ceiling, and then your middle finger is pointing to the left. Okay, those are all your positive positions. So if I have this robot and I needed to go from here to here, what button would I press? Would I press X, Y, Z, positive or negative?
X positive.
Right? This is the same as this. So you would move X positive. Okay. If I needed to rotate to the left, you would go Y positive. If I wanted to go up and pick up something, that's Z positive. So if I want to put it down, that's Z negative. Excellent. You guys got this. All right, cool. Any questions on it? Pretty straightforward. All right, let's move on to the next page. All right, so let's talk about the roll frame. This is very important. The roll frame never changes. It is the default reference for all other frames. Okay? It is the origin point. It is the reference point of where this robot exists. Okay, it is a 0, 0, 0. It is mastered at your Fanuc facility for this point. If you ever let your batteries die and this is in an awkward position, it actually loses that reference point. And that's not good. So, but just know this never changes, right? It is at its default position. This origin for robots is conveniently located exactly at the center of joint 1 and joint 2. And if I were to flip a robot upside down, I don't know, did Tenneco have that? Did they have an upside down robot?
I don't think so.
I'm trying to remember. I don't see it. Unless it was that machine that was back over by that door that was open. I think there was a robot upside down.
Yeah.
What happens to the roll coordinate if I flip it upside down?
It stays in the same
It stays with the orientation of the robot, right? So Z positive, it would do what? It would actually go down in the real world, but the robot doesn't know which orientation it's in. So the robot will actually go Z positive as up, but it's actually physically going down. Does that make sense? Mm-hmm. Cool. Any questions on this? All right, move on to the next one. Tool center point. Man, there's hundreds of different types of end of arm toolings. Okay, literally hundreds of different types. So if you guys ever go up to it's either Rochester Hills or I think that's where it's at. It's the Fanuc School. You'll actually see some different fixtures, right? This is one that's very common. You have another one that's holding a your marker. You also have a clamp style, right? Those are your very common choices. And around here, specifically in industry, welding, you'll see some type of welding. Okay. Robot has no idea what this is. Okay, no idea. So when you pull this robot out of the box, it thinks this faceplate, right? That is where the tool center point's at, right? It's the center of the faceplate by default. We have to tell it either through a 3-point, 6-point, or direct entry where exactly that reference point is from the faceplate out to where. Okay, so if we go on to the next slide, here are some very common different ways of defining that tool center point. So you have an actual fixed point. We have this downstairs for our robots. You bring in something sharp, right? Some pointy that's real close, so we can get real close to that tip. And then on a 3-point, we go here, and then we go some type of angle, either up or down, or some type of angle towards it. Okay, for a 3-point method. Does that make sense? The robot's physically moving this over to that position. Okay, so I have an actual example of how to set this up. Next slide.
10 minutes mark.
1 minute.
10 minutes mark.
Oh, wow, that went by quick. All right, so this is your teach pendant, also known as TP. This is your teach pendant. When you go to menu, there's an actual menu button on your teach pendant. You go to setup and frames. We're going to do this in our lab when we get downstairs. Set up frames, go on the next page. Here we can define if it's a tool frame, it's a user frame, or it's a jog frame that we're dealing with. So in this case, we're going to leave the tool frame, go on to the next point. When we go into details for that tool frame number 1, by default, it's all 0, right? We have to tell it where it's at. So go on to the next page. And the next page. So on a 3-point method, approach point 1, 2, and 3, everything is 0. Okay, go on the next page. When we actually, in RoboGuide here, we have this end of arm tooling. When we go to this position, okay, this point of reference, we actually program point 1, 2, and 3 by moving it around that point of reference. Okay. And then this is the XYZ coordinate system, how far away it is from that center point to your end of arm tooling. Does that make sense? You guys have any questions on this? Okay, cool. Real super easy to set up your tool center point. So let's go on to the next slide. Again, you're literally moving it from here, and by teaching it, you're literally moving it to a new position, wherever this position's at on the space. Okay. All right, let's go on the next slide. Okay, then user frame. So basically, a user frame is for your fixture or your workpiece. In this case, when we go downstairs and we look at user frames, you will see this. This is the conveyor that goes into the laser etcher. This is also the incoming conveyor where the part comes in. Okay, so those are going to be our user frames as a reference downstairs. So go on to the next slide. And then when we jog in different frames, when you press shift and you press coordinate right here, this actually will bring up the jog menu, and you can see what user frame number 3, jog frame number 1, and what tooling you're using. Okay, so let's go on to the next slide. All right, so user frame, same setup. If you're doing a 3-point, go on the next slide. Next slide. This right here in RoboGuide, we used a 3-point method. This guy right here, that is 0, 0. That is our origin point for that table. When we go this way, that is X positive, and when we go this way, right hand roll, this would be what?
Y negative.
Y negative. Yep, to that position. So if we were to look at it, it's actually what, 1200 millimeters, and then Y, it's negative 360 millimeters to that direction point. Okay, but your very first point is called your origin point. All right, so let's move on to the next slide. Again, referencing the exact same information. Okay, origin, your X positive, and your Y positive. All right. Go on, next point. So we're going to jog the robot in role, coordinate, user, tool, and of course, join. Join's really cool to see. kind of differ from these. You'll notice that when we move the robot. So remember to press the dead man switch to the center position. You're going to hold down shift, then whatever axis that you want to move. This right here. If you individually click this, it will go up by 1%. So if you want to make it faster, hold down shift and then hit speed up, right? Then it'll go all the way up to 50 to 100 really quick. Okay. And then to change the frame, it's an actual coordinate button that we'll press. Okay. So we'll have to enable the teach pendant, the controller down below, and then we'll watch how this moves. You guys have any questions on this? Comments, concerns? All right. We're going to pause the video. We're going to go downstairs and we'll resume it. Okay, we are recording. Cool. All right, so we're down in the plastics lab for Trine University. I'm here with a student. His name is John. I'm going to show John how to jog a robot safely and try not to crash into anything. And then I'll show you the different jog menus that we have. Okay. So when you pick up teach menu, one of the things, because it was running in auto mode earlier, if you want to take a look at this, we switched from auto to T1. And the same thing for our pendant, we had to go from off to on. Does that make sense?
Yep.
So those two things become active, then right here is your dead man. So it's an actual initial position. If I go too far, we stop. If I let go, it stops. Okay. All right. So if I were to hold it in neutral position and reset my phone, go ahead and try.
Okay.
Yep. And then reset.
Just this eye here.
No, right down here.
Down there.
Yep. And that gets rid of any type of faults that we have.
Okay.
All right. Cool. All right. If you want to know the actual positional data where it's at now, there is a button down here called POSN. Go ahead, click it. And that tells you exactly where this robot's at based off of the origin. Okay.
Okay.
So if we want to move this robot, if you hold down the shift with this thumb, yep, and you got to hold it down constantly. Then if you hit X positive, you notice it's going really slow. So hit your speed up or down. We're actually at 100%. So go down to, I would say 30, to go back up. So hold shift. Let go of shift. Hold down to, there you go. Okay. Now hold down shift again. Now you have to hold down X positive. You notice the robot's moving, and you notice the coordinate system changes.
Mm-hmm.
Okay. We are actually running the world right now. So if you want to change that, like go shift and hit this coordinate button. Where are we at? Tool frame. So if you try to jog it, tool frame is very similar how they have it programmed. Shift and X Y. Very similar. So go ahead and hit like Y positive. You notice this activation, all right? And this is rotating around. So if you were to hit coordinate again, which is user and hit coordinate again, join. Now, if you were to hit the Y, shift Y, watch what happens. Oh, you changed the speed down. Yeah. Make sure you go back up to like 30. There you go. Now, where's your X? You notice a change. You also notice where you're doing it, what's happening. This doesn't rotate. Well, it does. It rotates with.
Oh.
So
okay.
in join mode, all your axes moving together. Right? So if you were to actually move this to a different position, that would actually rotate with it. Does that make sense?
Yeah.
Okay, cool. Awesome. Do you have any questions on this?
No, just moving around seems simple enough.
Yep. It's always easier when you're programmed to always put it into roll. It's always easier. That way you can use your right hand roll. Cool. I think this is it for the video. I appreciate your time and looking at this. I appreciate students here for showing up for this class. Yeah, other than that,